Thank you, Herb, very much. It's great to be back at the TED on the Tyne. And I want to talk about extinction, or rather extinction and de-extinction, because I think one of the most exciting things that's going to happen in the next few years is the reversal of extinction. And don't worry, it is digital, because there's a key element of it that actually is a digital story. But sometime in the next 12 months, for the first time ever on this planet, humankind is going to drive a species extinct on purpose. It's never been done before. Smallpox wasn't driven extinct. It's still in the labs. And anyway, it's not a species. It's a virus. They don't really count. So we're actually going to see the deliberate extinction of a species of creature. Luckily, this is good news, not bad, because it's a horrible creature. It's called the Guinea worm. And you get it if you ingest water infested with water fleas that have the larvae of this creature inside them. And when the water fleas get into your stomach, the larvae come out of the water flea and they... Have you finished lunch, everyone? I just want to check. They drill through the wall of your stomach, and then they live in your body cavity, and they grow down your leg. And when they get to your foot, they cause a huge blister, and then out of this blister bursts the end of the worm. And it's really painful, and you get a burning sensation. The one thing you really want to do is put your foot in cold water. And of course, that's what the worm wants you to do, because then it's going to shed its eggs into the water where they can find new water fleas, and the whole cycle can begin again. And some years ago, there's no cure for this. But what you have to do if you get this is pull it out. It takes 3 months, and you have to wind it around a stick or a piece of gauze, day by day, inch by inch. Okay, if you haven't finished lunch by now, you certainly have. And a few years ago, a man named Jimmy Carter, who you may have heard of, set out to try and get rid of this scourge. It's a species that doesn't infect anybody else. Other creatures have their own guinea worms, but the human guinea worm can only infect human beings. So if you could get rid of it, you could get rid of it completely. And the Carter Center, started and run by Jimmy Carter, really zeroed in on this creature. And they are doing an incredible job, because the solution, the Carter Center set up in Africa, and there is one of its major, gleaming headquarters, and they educate people. And of course, what you want to do is you want to stop people putting their feet in water when they're infected, and then you want to isolate cases so that people won't give it to other people. But also, you need to filter the water so that people are not ingesting water fleas. So it's low-tech solutions. It's really simple. It's just a matter of education. And here, dracunculiasis is the name of it, the Latin name of it. And here are some kids who've got it, learning about it. And the result has been pretty spectacular. There were 3.5 million people in the world with this disease in 1996. By 2008, the number was down to 4,600. And it's still falling. Last year, it was just 542 people, nearly all in South Sudan. There are 3 other countries that had a few cases last year, but they will have no cases this year. So far this year, just 6 cases. There are going to be a few more. We're entering the season where you get more of this. But nonetheless, the betting is that by this time next year, this creature will not exist on the planet again. And that's really rather a wonderful thought. But of course, nowadays, it's not going to be that difficult to bring it back if we want to. Because we know from a discovery made 60 years ago last month that life is a digital phenomenon, that life has a recipe written in a quaternary code called DNA. And here it is. And so all we need to do, if we want to bring the guinea worm back under some circumstance, is put together this recipe and play it out, and we'll have the creature back again, if that's what we choose to do. And that is what we could choose to do with some other creatures that have already gone extinct. And I think over the next few years, we are going to do that. Human beings have driven a lot of species of animal extinct. In fact, the number isn't necessarily going up at the moment, although a lot of people think it is. It looks like, if you look at birds and mammals, which are the groups we know best about, that it peaked sometime around the end of the 19th century when we were colonizing islands, because most of the species extinctions that we've caused have been on islands, where we've introduced rats or cats or other pests to islands, to Hawaii, to New Zealand, to all these other isolated islands. The endemic fauna is very vulnerable to these introductions. So, for example, in the case of birds, we've driven 123 species extinct on islands. We've only driven 6 extinct on continents. That's full species, mind. You know, plenty of subspecies we've driven extinct, and there's plenty of local extinctions. We've extinguished things within countries, but global extinctions, we've only driven 6. So it's not too late to save a lot of these creatures. There's an awful lot who are hanging on. And this is largely thanks to the work of conservationists, so there's a lot of species which got very close to the brink and have been pulled back. Nonetheless, wouldn't it be great to get some of those 129 back? And that's the idea behind a project called Revive and Restore, which I'm lucky enough now to be an advisor to, although I've done absolutely nothing to help them so far, but I'm planning to. And Revive and Restore is all about trying to use genetic technologies to bring some of these species back. And until 5 years ago, I would have said that's a ridiculous pipe dream. It's still a long way off. If we're ever going to do it, it's going to be, you know, decades in the future. I now think it's just probably a few years away, maybe a decade, maybe 2 decades. But I don't think it's further than that because of 2 technological breakthroughs that I'm going to tell you about in a second. Now, Revive and Restore is the brainchild of a husband and wife team called Stewart and Ryan Phelan. Many of you will have heard of Stewart in particular. He was the founder of the Whole Earth Catalogue. He's the man who coined the word personal computer. He's a great Californian guru. He turns his mind to all sorts of things. He started the Long Now Foundation, which measures time with a 0 in front of the year, so that to remind us that we're living in a long period and we should try and think well into the future. So Stewart's a great thinker. Ryan is a brilliant biotechnology entrepreneur who's founded 2 online medical diagnostic companies, the last of which, DNA Direct, has now been sold to a bigger company. So when these 2 start something, it stays started, is the point. So, you know, you don't bet against these guys. And what they did just a couple of years ago was started to say, look, why can't we just investigate this problem? Think about whether it's going to be possible, and in particular, think about what we would have to do to make sure it worked all right and that it didn't cause more problems than it started. You know, that it didn't, for example, make people complacent about extinction, that it didn't bring species back in a form where they couldn't survive except in a zoo or something like that. So let's think through all the problems, and meanwhile let's develop the technology for de-extincting species. And the species they're focusing on first is called the passenger pigeon. Passenger pigeon went extinct 99 years ago, 1914, Cincinnati Zoo. The last one died. It was called Martha. And before that, in the early 19th century, this creature had probably been the most numerous bird in North America, possibly the most numerous bird in the world. It was incredibly abundant. The reason was the collapse of the Native American population, which had left abundant food in all the woods, which had caused this huge boom in the population. But it was a very unusual species. It seemed to go around in just a few huge flocks, maybe even one huge flock. And that was its undoing, because once the telegraph came along, it became possible for people who canned these creatures in order to feed the army to tell each other where the flock was and to move in and help themselves to the flock. And here they are helping themselves to the flock. So an extraordinarily abundant species, but a very nomadic, a very unpredictable one, which suddenly, before anyone realized that, you know, because it was quite often you wouldn't see passenger pigeons for years on end, and then the huge flock would descend on your farm and strip it clean. And so nobody realized that these things were on the brink of extinction till they'd gone. And as I say, Martha was the last one, and that's Martha in the foreground. But there are quite good museum specimens. And this guy, Ben Novak from the University of California, Santa Cruz, has sequenced the genome of the passenger pigeon. He did it from a cell from the toe pad of not Martha, but of the other one, of a male. And he was able to produce a pretty well complete sequence of what the DNA genome of a passenger pigeon is like. And that's the first step. And that's now quite sort of routine. I mean, Svante Pääbo was the first guy to do this with Neanderthals and with mammoths. 20 years ago, this was a weird idea that you would ever actually read the recipe of an extinct species. Now that's kind of all right. But it's going to get much harder if you go further back. Dinosaurs are way off the chart because, they're 65 million years dead and the DNA is totally broken up. With something that's only 100 years old, the DNA is really quite intact. But that's only the first step. The next step is to edit a genome till it looks like that genome. Because, when you sequence it, you've just got it in a computer. You haven't got it in biology. You've just got it in silico, as it were. So how do you get it into biology? Well, you take another genome and you start editing it. And this is where the key breakthrough has come in the last few years, or one of them. And that's these precise DNA editing techniques that have come on. One called CRISPR and one called TALENs. Until recently, genetic engineering meant kind of random trial and error changes in the genome. You knew what gene you were putting in, but you didn't know where it was going to land up. And you just hoped it landed in roughly the right place. And you selected with lots of trial and error to make sure that you ended up with the genes in roughly the right place. But what CRISPR and TALENs enable you to do is to go in precisely and respell a genome letter by letter in the exact right places. So what you want to do is take, and George Church at Harvard University is one of the people who's pioneering these techniques, and he's involved in this passenger pigeon project. And so his plan is to take another genome and turn it into a passenger pigeon genome by literally reading it out of the computer to tell what changes he needs to make. And obviously, what you want to do is start with the closest relative of the passenger pigeon, which is called the band-tailed pigeon. And it's about 1% different. Now, in a 2 billion base pair genome, 1% is, I don't know, I'm not very good at maths, somebody told me, but it's a lot of changes that you've got to make there. So, the plan is to take a band-tailed pigeon genome and, in the lab, just go through systematically replacing the DNA sequences that are different for the passenger pigeon until you've got a cell in the laboratory that has inside it the biological genome of a passenger pigeon. But the next step would have been even more difficult a few years ago, but again, suddenly there's been an interesting breakthrough. This is a guy called Michael McGrew, who's at the Roslin Institute near Edinburgh, just north of here, and working with the Central Veterinary Research Laboratory in Dubai. He's done something really quite clever, which is going to work in birds, in order to make one creature give birth to another creature. And so what he's done is he's taken germ cells from a chicken, and he's put them inside the embryo of a duck in the right place, so that when that embryo grows up to be a living duck, some of its sperm will be chicken sperm instead of duck sperm. And the consequence is this little chick here, which was born after being fathered by a duck. It looks like a duck, it quacks like a duck, but it bonks like a chicken, if you want to put it that way. And the next step is to knock out the germ cells in the host species so that this duck will only produce chicken sperm. And then, of course, the next step is to do it in the female as well. And then suddenly you've got 2 ducks who can produce chickens, which is a weird idea. But, of course, we don't have band-tailed pigeons in laboratories, and they're not an experimental animal. So this suddenly makes it a lot easier to talk about taking that passenger pigeon genome, which you've made from a band-tailed pigeon genome, bringing it into the laboratory and putting it inside the embryo of a duck or a chicken, and suddenly you're going to have ducks and chickens that can give birth to passenger pigeons. Now, it isn't going to be that easy. It's going to take years, and there's going to be mistakes, and there's going to be mutations, and you're going to end up with chicks that fail to hatch and things like that. There's going to be a lot of problems. But it is no longer impossible. It's no longer even unlikely that this will happen in the next 5 or 10 or 15 years. And it's not the only species. Revive and Restore has people from Australia who are looking hard at this creature, the thylacine, the Tasmanian tiger, which went extinct in the 1930s. There's very good specimens, so it's no problem getting hold of the genome of this. Marsupial mammals are, of course, a whole different proposition, and you've got to deal with the pouch and all that kind of thing, so the reproductive technology is a different problem. But this is starting to happen all around the world. And what about here in Europe? What creature would we like to bring back? And top of my list, and I think top of all Europe's list, should be the Great Auk. It's the only bird species that has gone globally extinct that bred in Europe in the last 200 years. No others. There's another one that's probably gone extinct, the slender-billed curlew, but it's not yet been officially declared extinct. They're still hoping to find one or two in Morocco. But the Great Auk was the northern penguin, a bird about that high, a flightless bird that lived in the North Atlantic and that bred on low-lying, remote oceanic islands all across the North Atlantic right up until 150 years ago or so. And its problem, of course, that being flightless, it was very easy to catch when it was on land, either for food or indeed for the downy feathers which were put into eider downs and so on. So the last great colony, which was probably they lived on, just close offshore islands around the European coasts in prehistoric times. But by modern times, they were only on very remote islands like St Kilda and Funk Island off Newfoundland and so on. And the Funk Island colony, which was the biggest one in the early 19th century, was wiped out by this trade in feathers for pillows and eider downs in the early 19th century. But there was another colony on an island called Geirfuglasker, south of Iceland. Geirfálskeri it translates. The Geirfál is the old name for the Great Auk. And because the island was said to be haunted, this colony was kind of left alone. But then nature did something really unkind. It caused a volcanic eruption under the island, and the island sank in the early 19th century. There were a few refugee great auks started breeding on other islands, particularly an island called Eldey off the southwest coast of Iceland, and word got out that they were on this island, and some specimen collectors went to collect them to supply English bird collectors, and the last one was clubbed to death in 1844. So the Great Auk is gone. But we have museum specimens. The youngest is about 150 years old, so that's quite a tall order in terms of genomes. There's going to be a lot more deterioration in a genome 150 years old than 100 years old. But there's already been some work on this, and although it's fragmented, the genome's there, and it should be possible to piece together what a Great Auk genome looked like, letter by letter, for the 2 billion base pairs that you need. And the Great Auk has a close relative, and it lives about 30 miles up the coast here on the Farne Islands. It's called the razorbill. It's a much smaller bird. It can still fly and all that, but we know from DNA that it's the closest relative of the Great Auk. So it's not impossible that you could take a razorbill cell and do CRISPR and TALENs techniques on it to try and just inch that genome towards the genome of a Great Auk once you know the sequence. And then we don't have to go and start messing around with razorbill embryos. We could go back and use a duck or a chicken to give birth to the first Great Auk. And it may never happen, and it may be too difficult for some reason, and nobody's actually on the case yet. There's a few of us talking about this, and there's a couple of universities sort of thinking about it, and the Icelanders might be interested, and the Canadians, and et cetera, et cetera. But it's just a gleam in a few people's eyes at the moment. But I have a dream that in about, well, certainly before I die, that the Farne Islands, just up the coast here, which have these huge colonies of guillemots and razorbills and puffins, will one day have a huge colony of Great Auks on it. Now, there are ecological issues with this. We have to think carefully about Is the habitat still there for extinct creatures that we want to bring back? Can we do this in a way that they will be wild creatures and they will plug back into their ecosystem rather than just be zoo animals that don't know how to go on? You know, they haven't got parents to teach them. Passenger pigeons, that's fine because the parents abandoned young passenger pigeons before they fledged. So they kind of learned everything as a peer group, as it were, of young pigeons in each generation of fresh. They were reliant almost wholly on instinct in that sense. But guillemots kind of train their young how to feed. Great Auks probably did too. So there's all sorts of issues. And people are saying, well, you know, maybe it deserved to go extinct. I don't buy that, actually. I think, you know, just because someone wanted an eider down doesn't mean we can't reverse the story. So we have to think very carefully about this, whether it's the right thing to do, whether it's sending the wrong message that extinction is not forever, for example. Nonetheless, I think it's an exciting new project that is just crossing the horizon and that it would be worth pursuing. Thank you very much indeed.
Fantastic.